In this video, we're going to take a look at the geometric series test and the nth term test. Now, these are generally the first two tests that you're introduced to when you begin your study of series and convergence. So let's take a look. Now, first of all, we have to be able to identify if a particular series is a geometric series. And what you're looking for is inside of your formula for the series, you're looking for something being raised to the nth power. That's going to give you an indication that that, in fact, is a geometric series. So whatever that is that's being raised to the nth power, we call R. That's the common ratio. And if that R, whatever's being raised to the nth power, is greater than or equal to 1, we say the series diverges. But if the absolute value of that R is between 0 and 1, we say the series converges, and we get a very nice formula. Grabbing my highlighter here, we get a formula for the actual sum it converges to. So let's put some examples to that. I want you to look at this first sequence. We have 3 over 2 to the n. I'm going to rewrite that because it's a little bit deceiving when you see it like this. I'm going to rewrite it as 3 times 1/2 to the n. That is going to be able to allow you to see the r just a little bit better. Now let's think about the sequence. If we start at 1, meaning with the first term, then we would get 3 times 1/2 to the first, and that would be 3/2. Okay. Now, if we let n be 2, so like what is the second term in that sequence? Then we would have 1/2 to the second, which is 1/4, and we would multiply by 3, right? And you would get the idea. We're going to write one more. So we would let n be 3, so there'd be 1/2 to the third, that's 1/8. And so we would do 3 times 1/8, that would give me 3/8. So you get the idea. We are adding these terms up. That's what a series is, as we add each of the terms in a sequence together. So can you pick out what R is? Can you pick out the item here that's being raised to the nth power? Well, absolutely. It's kind of easy to see when you write it like this. So we know that R is 1/2. So based on our rule, the geometric series test tells us that it diverges if R is bigger than 1. And if R is between, the absolute value of R is between 0 and 1, we converge. So this is a converge because, again, R is between 0 and 1. And now we're looking for that sum. Well, what sum does it converge to? Well, we can use our formula here. The a sub 1 is the first term. So the first term in our series is this 3/2 over 1 minus r, which is 1/2. Okay, so 1 minus 1/2 gives you 1/2. And so you got 3/2, and you flip and multiply, so you get that the sum equals 3. All right, so look at B then. Okay, similar series. But in this one, notice that if n is 1, I get 3/2. If n is 2, I get 3/2 squared. That's 9/4. If n is 3, I get 27/8. Okay, so now can you pick out R? R, the common ratio, is actually 3/2 here. And because it's bigger than 1, we know that this diverges. If it diverges, we can't find a sum. So we have to stop there. So that's our geometric series test. It's all about identifying the R value. That's going to be the cue to see if it converges or diverges. If it converges, you can go ahead and take the extra step to find the sum that it converges to. Now, let's also look at the nth term test. So the nth term test says if you take the limit as n approaches infinity of the formula for the sequence, and if it does not equal 0, then automatically the series diverges. So, very important point here. This is not saying that if the limit equals 0, then we converge. No. If the limit equals 0, this is saying, hey, go test using a different test. That's important. So the nth term test only proves divergence. Okay, let's look at a few examples. We have a series here. If we take the limit as n approaches infinity, I want you to see that we can divide each of these terms by n. So we got 2n over n plus 3 over n over 3n over n minus 5 over n. And that gives us 2 plus 3 over n over 3 minus 5 over n. Now we know as n gets larger and larger and larger, these two fractions are going to get smaller and smaller and smaller. In fact, they're going to go to 0, and we're going to be left with 2/3. And because it's not 0, because it's not going, the limit is not equaling 0, then we say the series diverges. Now, let's look at B. This is a very common notation with series. So let me explain what that means. That's a factorial. So for instance, if I had 5 factorial, this is what that would mean. 5 times 4 times 3 times 2 times 1. So when we have n factorial, let me show you how we have to deal with that. We have to do n factorial is n times n minus 1 times n minus 2, right? It's the number times 1 less than the number times 2 less than the number, and you get the idea, right? It would keep going. Now on the bottom, I want you to see we would have 2 times n times 1 less than n times 2 less than n dot 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 plus 1. Now remember what happened when we divided by the n's up here? We were left with really these two numbers in front of the n's. So if we look at ours and we were to divide by all of these n's, we would be left with 1 divided by 2, and that would give me 1/2. And again, because this limit does not equal 0, we say the series diverges. All right, let's look at just one more for our nth term test. We'll need the limit. And for this one, I want to divide by the 3 to the n's. Okay. I'm going to divide each term by 3 to the n. And by the way, I can do that because I'm doing it to every term. And so let's simplify. That gives me 1 minus 2 over 3 to the n divided by 1. And now as n gets larger and larger and larger, this denominator is getting bigger and bigger and bigger. This whole fraction is going to 0. And so I'm getting 1 over 1, which is 1. Again, this series diverges. So I hope this helps with the geometric series test as well as the nth term test. If you have questions or want to see more examples, please leave a comment below. Bye for now.